All right, we'll get going. About 5:15. Thank you all for attending. I'm Dave Campbell. I'm going to up here and talk to you a little bit about SQL Server and some SQL services, Sync framework, and other things going on. Zach Owens is up here with me. He'll be doing some of the demos, and he's doing some last-minute tweaks here as we stand up here. So we'll get to that stuff in 15 or 20 minutes. I've been doing the database gig for coming up on 20 years. Some of you can tell by all the gray hairs. A lot of these I just got in the last year or two here working on this stuff. But we're in one of these periods where faster is not just faster and cheaper is not just cheaper. And I mean, it's different, right? If you go back 20 years ago and thought about databases, that was sort of the time when client-server databases emerged. And the incumbents kind of looked at some of the client-server databases and said, well, those things are sort of toys. They only do 60% of what traditional databases do. But the thing that was interesting about client-server databases was the fact that they moved data out to the edge where the power was. So if you think about it 20 years ago in the late 80s, people started to get PCs on their desks. And the incumbents who were building the monolithic apps did a lot of work with terminal emulation and terminal services. And you can actually go out in 1988 or so and buy a 3270 board that you could plug in your PC and plug it into the terminal network and actually project the bits out to the edge. Well, the thing that the client-server database guys did is they came along and they actually said, no, let's move the data out there. And they had to go break a bunch of assumptions, and they had to invent a number of things in order to pull that off. So we couldn't assume TCP/IP back then. We had Banyan Vines, DECnet, IPX, all SNA. Even getting bits from one box to another was a challenge. So I had to define formats and protocols. They had to abstract levels 3 and 4 of the network layer. They had to do a bunch of things to make it all work. In fact, they had to go off and build authentication and authorization mechanisms in the database server because they weren't part of the trusted base of the monolithic apps. The PCs that were on people's desktops were not. So there are a bunch of things that shifted. And you could look at it one way and say, oh, gosh, that thing's not a real database. Or you could look at it the other way and say, what does this enable? What sort of new scenarios does it enable? And another thing I could sort of put next to this is we've had a team off building SQL services for over 2 years now. And what is fascinating is how much unlearning and relearning we've had to do to move from a team that has built shrink-wrapped enterprise quality software for a decade or more to a team trying to build and run and host a service that's live 24/7 by 365. There's no off switch on this system. So we have to patch it and upgrade it while the whole thing is running while keeping data available at all times. So this is one of those cases where things are different. And what I want to get across in the next hour and 15 minutes is give you a sense for how it's different both outside in and inside out. So as I've walked the halls today, there are a bunch of people who are thinking, okay, is this just me taking a database and hosting it up there? Is this just me taking an app and moving it there? Isn't it just hosting? It's not. It's different. And what I hope to do here is show you how it's different and what sort of new scenarios we're trying to enable here. So we'll start talking about the evolution of a database management system to what we've been calling a data platform. I'll talk about what that is, what are the components of it, and how the data services fit in with that. How do we then take the data platform and extend it into the cloud? And we'll show a demo of that. I want to talk about new developments in database and synchronization technologies and what the changes are with respect to app patterns, application patterns and data patterns, which I think are fascinating, something I've been following for the last decade or so. And then basically talk about some of the new requirements and challenges that we face. And application developers, many of you in the audience face these challenges. In fact, what we'll do is we'll start there. So a little bit of a story. Before I came to Microsoft, I worked at another company where we had an enterprise database product. And our company, actually it was digital, for those of you who remember, I worked on RDB. For those of you old enough to remember it, we actually built a billing system for one of the satellite providers and spent probably close to 2 years developing the billing system, understanding all of the transactions, understanding everything that happened, laying out the schema in excruciating detail before we ever started writing code. In today's world, you can't afford that. Someone comes up to you and says, hey, look, I need an e-commerce site in 3 days. I need this in 2 days. So latency, compressing things, very much affects people developing applications and operational staff running applications. So you have unpredictable usage and scale. We've seen a number of internet properties over the last 5 years basically explode in popularity and then collapse because they couldn't meet and maintain the scale requirements. Secure data access is a huge challenge now as people are taking data and data is being pulled out to the edges. How do we keep it secure in the face of physical loss and such? And of course, reliability, availability, and supportability. Service uptime is critical in this new world. From the user experience perspective, the benchmark, or the thing that I'll go back to, I think it's a very good example, if you will, is the experience for those of you who are using Outlook and Exchange and use Outlook in cached mode. So if you go back 10 years or so when you had a fully connected client, if anything happened with the server, with the service, or the network, you were basically out of the water until something came back. And in this new world, even if we can assure 100% service availability, if someone comes along just outside the building and cuts the fiber with the backhoe, that's a problem. So how do we use offline, both in clients, small clients, servers, and large applications, to help weather those, such that utility doesn't drop to zero immediately when you lose a connection? And how do we build the best experience depending on whatever device you have at hand? Again, I'll go back to Exchange, is a great example of this. So my mail data is all backed up. I don't have to worry about it. I don't have to take care of it. If I'm carrying my phone around, I get the best possible experience I can get on this form factor. If I have my laptop, it's the best experience I can get on that form factor. And I can walk up to any web browser and get a very rich experience there. And we refer to that as a data hub scenario. Now, that scenario is specific to email and calendaring and tasks and such. And the synchronization, to get that all right, to make it all work, probably took hundreds, if not thousands, of person years. Basically, it took us 10 years to get it all together and get it all working well. What we aim to do in the data platform is to build those pieces into the platform so that you can build solutions that are not just email, tasks, and such, but whatever your business application has to be, without having to spend person years on how to figure out the sync piece, how to figure out how to scale the back end and such. And then, as I mentioned before, reduction of latency in terms of getting the business solution together, and perhaps more importantly, on the business processes themselves. I'll get into that in one of the later slides when we tee up the demo. And then in terms of application development, more and more complex data types being supported. So I talk about it this way. If you went in, could go travel back in time 20 years ago and could tell someone that they would carry around tens or hundreds of gigabytes of music, perhaps thousands, tens of thousands of tracks, and a little device that was this big, and you'd have basically relational database technology helping you manage all of that, that would have looked at you like you were crazy. And that's just 15 or 20 years ago. So again, these things, if you watch the curves in terms of the capacity increase and reduction in cost and such, you'd say, okay, it's a smooth continuum. But there's a point at which it enables things that weren't possible before. And we'll talk about that in the context of what types of data are we storing, what are the services we want to provide over those data, and how quickly can we put the application together end to end. So I talk about a data platform. Just what the heck is that thing? So when I came to Microsoft in 1994, we had SQL Server. And it ran on small servers, and it ran on a desktop. And you probably can't read it. Small font, little thing in the middle. And you could store any type of data you wanted in it, as long as it was relational, tables, forms, and blobs. And you could do a few things with the data. You could query it, you could load it, you could back it up. So this was a standard database management system. Over time, we've added capabilities to the system at all of these tiers. So the phone that I showed you a minute ago, I have a version of SQL Server running on this, the compact edition. We now have SQL Server running on mega services. We can natively store XML. SQL Server 2008, we can natively store files and manage them. So the age-old question, I've got some unstructured content to store. Do I put it in the database as blobs, or do I put it in the file system and store the file name in the database? We tried to just completely answer that question, take care of it. In-memory technology coming on. Multi-dimensional storage we use for analysis services. And if you think about the services over the data, things like analysis, protection, query, backup, load, mining, integration, sync, caching coming now, CTP2 of Velocity we're announcing this week. It's our in-memory caching technology. And all of these things come together. Now, you could look at it at one level and say it's just more stuff, right? The trick here is in getting things horizontally in 2 dimensions, at least 2 dimensions. One of the dimensions is on the device. So we're not just talking about synchronization between the desktop server version of SQL Server and another server version. We're talking about the ability to take something, bring it down in the right form on your phone, be able to bring it all the way up to the cloud. And we're also talking about it in terms of the life cycle of data, from the point in which it's captured to the point at which it's archived. And so when we look at that, I want to just take like 90 seconds here and talk about this model and policy-based management piece. You'll hear a lot about that. For those of you who are familiar with SQL Server 2008, one of the things that we announced was this notion of policy-based management. So SQL Server, server per server, is very easy to manage. We have a lot of people now who have thousands of SQL servers in their enterprises, and that's a challenge at that scale. But if you look at it, most of those servers fall into a handful of classifications. There are the types that are just under a developer's desk. There's sort of the tier 3 app servers. There's the mission critical server. So if you could define policies for each of those classes and then bind a particular server into that class, it becomes much easier to manage these things at scale. So we call that policy-based management. Now, we've also done a lot of work in terms of building a data model, the entity data model, and then using that across the entire life cycle. Now, people today have just seen that as a means of accessing data. Going forward, we will describe more and more of our services in terms of this entity model. Now, let me give you a sense for what we'll have in the future. So you can imagine us defining a customer in the model and then being able to render it in the database, but also be able to take that customer and refer to it in Report Builder, be able to build it into an information cube. And then when the customer reaches a point, based on some policy, maybe that they haven't been active in 5 years, I'll want to move them into deep archival in some other storage. Again, we'll use that model end to end to pull that off. So you won't have to re-describe the customer for every time you go through that. Okay? Now, the next piece, I talked about the data model and what we would do with that. And I talked about policy-based management. So here's the piece that will come next. So now we have a customer. Or let's start with an account. We'll say we have an account. And one of the things we have in an account is a credit card number. And we can tag that credit card number and say that it is financially sensitive information. So now in the future, we'll be able to define policies based on that tag, that attribute of financially sensitive information, whereby we can write management policies that say that any database that contains a model which has financially sensitive information in it, all backups must be to encrypted form. Any connection into that database must be over an encrypted channel. And so this is bringing together the models. And if you think about what you can see this week with respect to Oslo and the modeling platform, we'll make it much, much easier for developers and administrators to write, author both the models and the policies that go with it. So you'll see a lot of this come out over the next 5 to 10 years. And it's starting now, and it's going to be an amazing transformation in terms of how we build apps and think about it. So this presentation is meant to cover the data platform all up. We're going to focus a lot. It's going to be biased towards SQL services and the new scenarios. And the reason we're doing that is we imagine a lot of people in the audience have a lot of experience with SQL Server. And since it's a services-centric PDC, we want to focus on that piece of it. But we'll tie it all together in with the existing assets, SQL Server and SQL Compact Edition and such. So if we look at SQL services, those of you who attended the keynotes this morning, I happened to see a version of this slide several weeks ago, and this was funny because it came together, and I took a picture of it on my cell phone and sent it around to the team. Look, we're front and center right here at the top. So it was pretty exciting for all of us who've been working on it for a long time. But within SQL services, we will have more and more data platform services that make sense in the context of this services world. So Bob Muglia today talked about reference data as a service. So you can imagine that reference data as a service makes more sense in a services world where I can get at it from any place where I have an internet connection than it does necessarily within an enterprise when it's all sort of locked up. Now, we, within Microsoft, have our own reference data system that we use for our own internal systems. But you can imagine us providing a reference data and things like data cleansing perhaps in the future. reporting, mining, ETL. Now, we announced and actually put up this morning a SQL Services Lab with some incubations and some new technologies in this space to give you an appreciation and a sense for where we're going to be moving in the future. I don't have the URL in my head, but I'm sure if you search for it, you'll find that it's SQL Services Labs. So it is, in fact, the data services tier and extends the data platform to the cloud, which we talked about. And we'll talk about some of the services and capabilities here pretty quickly. So when you think about a database in the cloud, the thing I want to go talk about is, so think about we started with client-server databases and how the client-server database had to break and remake a number of things. So if you think about it, client-server databases had to invent formats and protocols. And the formats and protocols were so difficult to parse, you needed client libraries for the universe of clients that you wanted to reach. Now, on the internet today, there's a lot that we can take for granted. So we can assume TCP. There are well-defined formats that we can use. There are interaction patterns, means to actually bind to and consume services. REST, SOAP, APP is a rendering format, Atom Publishing Protocol that we use. And so what we want to do is reduce the friction in terms of going and connecting to the database service. So things are definitely different in this world. So one thing, this one's a pretty easy one to highlight, is the characteristic latencies on the internet are much larger than they are on the LAN. So in a client-server LAN environment, your characteristic latencies are in the millisecond range. On the internet, they're tens, if not hundreds of milliseconds, depending on distance. And so things like server cursors, which make a lot of sense at a millisecond cost to go round trip, may not make sense when you're talking 100 milliseconds to go round trip to go get the data. So those are the sorts of differences that we need to reconcile. So SQL data services, one of the things that we are focusing on, now it's been said several times, it's based upon SQL Server technology. It's not off-the-shelf SQL Server. We've pulled it apart and we've pulled it, put it back together again in new ways. Now, we do wind up having real database capabilities, real queries, a query processor, and perhaps most importantly, transactions, so that you can be assured that your requests complete or they don't atomically. And we are offering a business-grade quality of service, and particularly as we come out in a live service. And talked about some of the business model pieces. It will be a consumption-based model. And service interop we'll dive into in a bit. But I spoke that it's very easy to go address, very easy to go bind to, and standards compliant. So in terms of enabling applications, this is the one slide where I want you to say, OK, it's not about me just taking my database, my stored procedures, and everything, just moving it up there. Okay? I want you to think about what are the new scenarios. What can I do today that's hard? So if you saw the keynote this morning, the gentleman from Red Prairie was saying it's very, very hard to connect suppliers, setting up VPNs and managing them. Someone's nodding their head out there. And it's interesting, because what you do in that case is you secure the pipe, and it's point-to-point, and it's really painful. Now, if you have an endpoint that you can trust, you can exploit the asymmetry. It's typically much easier for you to get at the internet than it is for you to set up a trusted pipe between two corporations. So we can extend existing solutions via the cloud, getting things to scale. And we can create secure data hubs. That's the piece where we can coordinate. Now, we've been speaking with a number of ISVs. The place where this really resonates is in the PLM space, product lifecycle management, and EDA, electronic design automation. So these people are doing a lot of work in terms of coordinating designs. And quite often, you see a lot of structured data being exchanged, whether it's production data or quality data going back and forth. And so secure data hubs are very, very interesting in this particular space. And finally, this notion of low-friction deployment and scaling. So part of our data services layer is that we will build in the ability to provision new tenants and make that friction-free. Now, here's sort of the thought experiment here. If you were going to go off and build, let's say you're going to go build an ASP.NET application that you want to host in a multi-tenant fashion. So in today's world, you pretty much have to understand how you're going to scale that, how you're going to partition it, who you're going to host that with, and how you're going to keep the thing growing if you become tremendously successful. One of the patterns that we want to bake into the data service is the ability to instantiate new copies of models on behalf of tenants and just make that completely friction-free. So as you scale in terms of signing up new customers, we can just scale with you, and you will not have to provision to peak or provision far enough ahead to meet demand. That burden falls upon us. And the advantage, it's sort of an interesting thing. If you're doing it on behalf of one service, on behalf of yourself, it's very, very tricky to get that demand forecast correct. But if you can aggregate demand forecasts from a number of different people, there's a probabilistic way that you can do it that is much closer to what the actual demand curve will be. And so we can actually get that more accurate and sort of pass that on you. You don't have to worry about it. So the point here is low friction is not just easier to deploy, it changes things. In terms of the developer experience, interop and choice are critical. So we talked about REST, SOAP, HTTP, standard formats and protocols. We really want to enable and empower others to come and connect to this. So a couple of minutes ago, I mentioned that in the client-server database world, the client-server database vendor had to make a client library and distribute it for every client machine that they wanted to go talk to in the ecosystem. In this world, if we can publish a very simple format and protocol, people can go build libraries, build clients, and have the community ecosystem build out around it. So one of the things that we've done is actually built some Ruby libraries, active resource, active record, and you can go to GitHub SDS team and take a look at that. Those are available as of today. So if you're a Ruby fan, you can do that. We've got people who will be showing access to the service from PHP and Perl and other sorts of things. So it's very easy to get at. Now, if you are a Visual Studio developer, we will build in the integration such you'll have a very rich experience in terms of development. So in this, in the community-based library examples, being able to get at it from any sort of development environment, we get reach. And within the Visual Studio environment, we'll get a very rich experience as well. So that's part of the art here, is making it both available, low friction, anyone can get at it, and then giving a very rich experience as well. So here's the setup for the demo. And we're going to just kind of look at slices of this. And what I want to start with is the friction around a real business scenario and how we can take it out to the point where we can remake the scenario. So today, photojournalism, or up till today, it was a case where most of the sites or people who would consume photos from photojournalists were contracted directly with them because they conceptually had a pipe from whoever was taking the photo through to where it was going to, what media outlet was going to be using. And if you think about photojournalism, latency is super important. So if there's a very large event happening, big news, you want it to be able to get the photographs to go with it quickly. So in this world, what we want to do is sort of remake this ecosystem such that we can have a number of freelance photographers, if you will, and a number of media buyers. And if we can reduce the friction and reduce the latency, we can make a marketplace out of this. Now, the interesting thing is, you can imagine in this business model, you could set things up such that if someone takes an incredible photo of some particular event, someone else could come along and want to purchase exclusive rights to it. They may want to spend a lot more for exclusive rights than the shared rights to it. So the idea in pulling this off is connecting things up into a data hub such that we can bring together the media buyers from the producers. And so in this application, we have media buyers who will be able to get at this application from a very lightweight, low-friction application. We have photographers who will be out in the field who want to get a photograph up very quickly to an editor for review or get it posted so someone may purchase it. We have another application which is rich that allows a photographer to spend more time cataloging some of the things that may be used more in a stock photo situation. And then people looking at the business all up and doing business intelligence and analytics on what's happening within the business. And all of this is coming together in one of these data hub scenarios that we talked about. So with that, we'll kind of dive into it a little bit. And the first part of the demo is actually going to show us what the media buyer experience would look like in this Trey Research application. So Zach, take it away.
Cool. Thank you. Well, it's very exciting to be here, especially at PDC. I'm a technical evangelist, so in my role, it's all about working with people who are looking at the future and early adopters. So I know that's a lot of you in this crowd, so it's really an honor to be here.
See if I can find the right button.
Yeah, we're on D.
That should be D.
Okay, let me just make sure I'm projecting.
There it is. Right,
One more time so I can see it locally. Okay, so as Dave mentioned, the first piece of this application that we're going to look at is the customer application that our media buyers use to browse the photos that have been submitted by different photographers. So in this application, architecturally, what we've got here is a web application running a Silverlight interface, and this is connected directly to SQL data services on the back end. So Trey Research decided to use SQL data services as their data platform so that they didn't have to scale out and scale up to support the high user volume and searching and queries of the people who would be using this application. So as you'd expect, there's a mix of metadata, there's binary data in here. It's the structured and unstructured data all coming together. So I've done a search here, and as you can see as I browse through the photos, it's got my metadata. I can search business. As we know, the business world is doing great right now. If I look for stock exchange, let's see. So I've got stock exchange photos. At this point, someone could add this to their cart, purchase the image, and be on about their way. So this offers an interface where people can really hammer on it and do a lot of searching and queries, and it doesn't affect Trey Research's infrastructure locally. So let's take a look at what a query against SDS looks like. So right here, what we've got. I know there's been a lot of talk about join queries and capabilities within SDS, and what we've got here is a query that does do joins. So it's not just a place to dump data, it's actually a real database in the cloud. So if we look at this query, the first thing we start out with is image content. So that represents each of our images. And in that image content, we're filtering on its metadata. We're saying we just want the images in the US for this. We're just looking at date, time, and then we look at our next entity, and that's our image tags. So in here, we want to look for the photos of stock exchange. And now this is really where things get cool if you're a database geek, like a lot of us in the room are. So here we're using a join table, which is essentially a link join table or entity to represent that many-to-many relationship. And then down here, you can see we're actually using our image tag ID and our image content ID like you would expect of a database service. So here you can see this is an example query doing joins, a lot of, and it's a nice syntax too. You can see you can separate out the where clause. This is actually valid SDS syntax.
So the interesting thing here is this, for those of you who haven't looked at the data model, we actually have a model within SQL Data Services today, which is this notion of authorities, which is a name that you own, and then containers within the authority. And then you can have entities of many different kinds within a container. Now, if you restrict here, if you look at the of kind sort of operator on the entities within the container, you can restrict it based upon image tag, in this case, image content, and wind up with what looks like a logical extent, roughly equivalent to a table. And then from those entities or all of that kind, you can join across them. That's what you're showing there.
But there's a lot of flexibility there. So as we were developing this demo, we came across a point where we wanted to add photographer specialization as one of our attributes. So we were able to add that to our entities in a very flexible way. So the entities that didn't have those specializations attached to them, there was no impact on storage size or any sort of modeling. So it provides a very flexible modeling environment as well.
So for those people in the room who have tried to build sort of distributed data systems on traditional relational database technology, and the challenge of schema evolution in the large and distributed systems is really painful in order to make sure that you have equivalent schemas everywhere to be able to do this. The example, the advantage here with this system is that we can just add things dynamically and round trip it in a very flexible way.
Exactly. So let's take a look to prove to you that this is really a data service and to get at Dave's point in terms of this being open to other programming languages. If we just go ahead and run this query, it's going to execute directly in IE against the REST API for this service and returns the same image. So
that actually went up to the, did you hit for that?
I did.
That was pretty damn quick.
Yep.
Good.
So that's that.
All right, good, good. Thanks, Zach. Well, let's go forward a little bit, and we'll take a look at some of the other pieces. So that was our demo part one. So that was just connected. It was a web Silverlight application connecting directly into SQL data services. What we want to talk about now, and I think again, going back to the example I mentioned earlier around Exchange, how do we build these systems that have occasionally connected applications? And the sync framework is something we've been working on for a long time. We announced the first CTP of V2 of the sync framework recently. And it's a very easy and efficient way to move data around. And the thing that I want to point out here is that for a long, long time, people have been building sync. And it's a funny story to me because I run into a lot of people who have, over the years, built their own sort of quote-unquote database. Like, I have a database too heavyweight. I'll go, how hard can this be, right? And many people I see who start there, several months into it, when they start building their own sort of thing, they realize just how hard it is. Sync is the same way. People say, how hard can it be? Once they get in and understand all of the corner and edge cases, they're, several months later scratching their head saying, man, this can be very hard. And figuring out how to factor sync in a way that pulls apart and separates all the orthogonal concerns is really, really hard. Most of the sync solutions to date have pulled together protocol and interaction and how to represent the synchronization state and how it's stored in the metadata. Lev Novik, who spoke earlier on the sync framework, was a principal architect in this space. I think did a fabulous job of pulling apart the concerns such that in the sync framework, you're able to use your own store. You're only obliged to carry the knowledge and opaquely store it and give it back. You can use your own transport to get information from one side to another. You can use your own model in terms of how to store and what you are going to synchronize. And again, it's this notion of this smooth continuum between reach and rich. And so if you choose the SQL Server data platform, a lot of that stuff just sort of comes for free. But if you need to synchronize off to some other system, there are ways to get into it and to be able to pull that off. And I think the team just did a great job of factoring this. And the proof has been borne out in terms of the people who have been able to go off and build very interesting providers quickly with the synchronization framework. We have providers now that are producing data for the live mesh. And you'll see some of that in the next couple of days. Data to and from other services, from SQL Server and such. And so this is a really key piece of the technology. So we think about offline-enabled applications. Services and networks are not always available. In particular, the case I talked about when someone comes along and just cuts the fiber. And local data, when you have it locally, it can be accessed much faster, reliably. And here's an example on the lower right where we're talking about an application which must be connected. Okay? And that's fine as long as you have a connection. But when you lose the connection, your utility in that application immediately goes to zero. So if you've got a browser-based application, actually, here's an interesting. I always get in these fights with people who say that, oh, we're just going to have ubiquitous connectivity. And like 3 or 4 years ago, they gave me the example of, well, now you're going to get internet in the airplanes. I think we're farther away from that now than we were 3 or 4 years ago. But the point is, there are times when you will not have a connection. And if you don't have the ability to have a local cache of information, quite often you pretty much have no utility until you can get back on the network again. So Sync Framework gives you the technology to be able to build these offline cache mode applications without having to invest the tens or hundreds of person years to go figure out how to pull it off. So one of the things, actually let me just go back and show you one piece here, if I can do this, that you see in the lower corner is this notion of having the store there with it to be able to synchronize into. That's another part of the data platform. So we have Sync Framework running on devices like this, SQL Compact Edition running on devices like this, so you can build this in as part of the application as well. So with that, we'll move on to the next part of the demo. And here, what we're going to focus on is a view of an occasionally connected, rich application that photographers would use. So when you take a photograph, you want to be able to queue it up. You want to be able to tag it. You want to be able to mark it with IPTC metadata, if you know what that is, if you're in that space. And you may want to do further organization with a rich application and then be able to synchronize and push it up. And you want to be able to do this whether you have a connection or not. So in many cases in photojournalism, you're running around, may or may not have a connection. You may jump out to some place where you can get a connection to push an image over to an editor for review. And so this is very critical for this piece of the application. And again, it syncs to the data hub backed by SQL Data Services. So with that, I'll turn it over to Zach again, who's actually quite busy taking it. You just did it. You're going to tag an image right now?
I am. So as you can see, I'm uploading an image. I'm using that photo, that mobile app right now, and although I can get the images up there quickly into the cloud, no sort of connection to anything around here other than a network connection, it is sort of a more clumsy form factor than doing the same thing on my laptop here. So let's actually take a look at the laptop and see how some of my photos looked in our web app. So what we've got here is, this is an image that we took a couple days ago as we were setting up, and we've got it into my laptop now. I've prettied it up in whatever program I wanted to do that in. And now I'm ready to import that into my Tray Research photo management application. So this application here is a WPF application that runs off of a local SQL Server Express database. And this Express database, so Express is free, but it's super powerful. We're going to see that we're using spatial features inside of Express. We're using the file stream data type that Dave talked about inside of Express for storing our blob data. So with this application, I've already done what I wanted to do to edit the image. So now this is just all about importing the image and giving the metadata that Tray Research needs to actually load it onto our site. So that's the folder that photo that I just showed you was located in. So I'm going to tag it for PDC. Then down here on the map, I'm going to say I was in LA. So as you can see, when I click on this map, it populated my country and state. So the SQL Server Express database has all the polygons for the countries and states, and it just looked it up based on the point that I clicked on the map. So then I'm going to select, this is business and entertainment, technology, little mix of all that. So when I hit save, what it's doing is it's storing that image and all of its metadata in a SQL Server Express database right here on my laptop. Normally in your application right now, you'd automatically kick off the sync framework, and it would go upload that data to SSDS, or to SQL Data Services, and then it would be available for our customers to browse and buy.
So you wouldn't have a sync button?
I wouldn't have a sync button.
Yeah.
So because it's a demo, I've got a sync button, and I'm running this thing in debug mode in Visual Studio with a breakpoint. So when I click this, it's not a bug. It's meant to do that.
That's right.
Okay. Sure. So what I do is I caught this breakpoint at a piece of code I just want to show you real quickly. But first, let's take a look at our solution here. So this is the sync portion of our solution. And I think the most interesting things here to point out are that we have, it's called Sitka Provider, which was the code name for SDS before it was released. And then we have SQL Provider. So as Dave talked about, in the sync framework world, you can get providers from different people, and you can just wire them up. So Sitka Provider, this is old. This was written months ago for another project. We grabbed it, threw it into this project, and now we can talk to SDS. And then the same thing for the SQL Provider. The things that we had to do when we implemented this application were add some custom data translations and mappings to, say, take the blobs from SDS and turn those into file stream in our SQL Express database. And then a lot of the code then that we did for our application is in this Sync Manager class. So if we look at the Sync Manager class at one of its main methods here, so at the do work method. So the things here, Sync Orchestrator, that's part of the Microsoft Sync framework. And then this brokered hookup, again, that's part of the Sync framework. And all we do is end up passing it our SQL provider and then a reference to our Sitka provider. And then the Sync framework kicks in and does its thing. So if I let this thing go, we'll see we got our little sync icon spinning, and it's going to go upload that to SDS.
So the idea there is that, I mean, it's not that hard to write a provider,
right?
But it's like 100 times easier to wire two of them. I mean, it's just like a couple of lines of code to take two providers if you can get your hands on them. You just, broker them together and say synchronize. Right. So that's the beauty of being able to pull this off. And you said you do a couple of data translations.
Some data translations and mappings. Yeah. And we actually, for this application, because we knew it was going to have a local client, we knew it was going to have storage in the cloud, so we actually built our entity model in SDS to closely represent what we were going to have in our other data platforms to make it really easy to do that sync. So in this application, that was the easiest way to do it.
So how much code do you think you have in sort of the data transformations and translations between the two models?
There's a couple of files there, so a couple hundred lines of code, but nothing that was
So a couple hundred lines of code, which is in your head because that's in the domain,
sure,
in terms of how you're going to represent things. And then you got your hands on both providers, and then just a couple lines of code to wire those together. The key thing there is if you tried to do this before we had the sync framework and the data hubs, this would be, could be a person year or two of work just to try to figure out how to get these things to go. And I guarantee you wouldn't get all the edge conditions right. Because conflicts, all that sort of stuff is just difficult.
Exactly. So let's see if I can prove to you that we got some of these in here. So if I actually do a query here on PDC images, because that's what I tagged the images I was taking with this phone. So it looks like we've got a couple of them in there. So that all uploaded directly to SDS. You can see I took the one of Dave and I while he was talking, setting up here.
Very good.
We've got a lot of people working hard, building demos. So there we go.
Great. Fantastic.
Thanks.
All right. Thanks, Zach. Okay. So now, just to sort of wrap things up, we're going to take a look at SQL Server 2008 and how it wires in to this application. So we released SQL Server 2008 a few months ago. We had 4 key themes for the release. Enterprise data platform is sort of, how do you get the thing to be more scalable, more reliable, more available, release over release? So that's sort of just always pushing the bar on this. The thing that we did in SQL Server 2008, which represents tremendous innovation, so the first step in it is this notion of the policy-based management. So I've got that listed there as well. On the dynamic development front, we see more and more. It's actually interesting. Before I was working directly on SQL data services, I had another role trying to figure out where we should take SQL Server and things there. One of the questions I kept asking the CXOs when I talked to them about where the budget was going and this and that, I asked them, how important is time to solution to you? And the answer I got back over and over was that I'd be willing to write a much bigger check if you can give me a solution in 4 weeks than 4 months. In many cases, 4 months isn't even going to meet the business needs. So the ability to put things together quickly, I say build it fast and make them last, is really important. So we spent a lot of time focusing on that in the platform.
Which, by the way, is exactly how long we took to build this whole application end to end. We had a little bit of code to work from, but we had 4 weeks and about 4 developers.
I think I have the time to share another little anecdote. So a couple of years back, I was in London at a very large financial institution. They hired a brand new CIO, and he came down and he was, let's say it this way, he was a fan of another database platform. And he came in the room and he just tried to kick my butt, and about 90 minutes later he kind of realized I might know something about databases. And I said, okay, hold on, just take 6 to 8 weeks, just work with it, call me up if you have any problems. And the guy went from being, look, I'm going to throw it out and go with the stuff I know will work, to actually he was in one of the videos for the launch. And the reason was, it was the development agility. We convinced him and showed him that the platform could scale. It had the enterprise qualities, but it was actually the development agility and dynamic development which really won him over. So that's something we push on. This notion of beyond relational. Databases have done a very good job of storing a certain class of data. There's so much data out there. I say it this way. If you go back 50 years ago, the cost of data acquisition was actually quite expensive. We paid humans to turn information in a digital form so we could process it. Today, the cost of data acquisition has effectively reached 0. It's just out there for you to grab. In fact, many things that are analog phenomena are captured in digital form. So if I make a call on my cell phone, it's going over a digital network and such. And so more and more, we have a large volume of data that's got to be managed within the database of one form or another. And there's a great debate within the database community and one size fit all, this and that. But this is something that's really critical in terms of building applications. And then finally, once I have the data in, it's how do I make use of it? And again, a real quick story of how reducing latency is not just faster, it's different. So in SQL Server's case, we used to run SQL Server, run the business on Excel spreadsheet. We go into the meetings, we print it out, we do the deal a meal of the Excel spreadsheets and paper, and everyone look at it. And someone would look at some cell and say, how come this thing's 30? Usually it's like 18. And what we did when we got reporting services, we started running the business over to reporting services. And it was kind of funny because we had all these people trying to outdo each other on reports and queries and such like that. And it took a while for us to winnow things down into a set of operational reports that had drill down, and KPIs, such that we didn't have to say, hey, that thing's usually 30, today it's 18. We'd see it in the KPI. And we could drill down to it in the meeting. So what used to happen in the meeting is someone says, hey, that's 18, isn't it usually 30? Yeah, maybe you're right. I'll look in and we'll get back to you tomorrow when we meet. Into being able to drill down specifically into the operational data to find out what was going on.
It's the same for the product teams. When you file bugs on Connect, so I know if you talk to Microsoft people and you tell them there's something going on, like a feature request or a bug, and they're like, file it on Connect, file it on Connect. It's because there are business processes built around that where PMs are running reports out of reporting services where they can drill into those things, and it's an example of where
I'm going to give you the dirty little secret. So part of what we look at in these operational meetings is the Connect data and how many people vote on this. And I know some people stuff the ballot box. I'm going to write a blog entry, like this thing's really nagging me, so everyone vote for this. And we come up with these disproportionate things. But it really does change how you run the business. So this pervasive insight is sort of the key there. So with that, we talk about beyond relational, going beyond and doing a great job of blob and file storage. Talk about file stream. That's something you look at with shipping in SQL Server 2008. Semi-structured data, in using XML within the database, and then rich structure. The next thing I want to talk about real quickly is spatial. So in the spatial world, geolocation around services, geoservices, is super hot right now. And I think space and time will both become very important types within the database, sort of built-in types and such. So in SQL Server 2008, we announced spatial support, and you've been seeing some of that in the demo thus far. And so again, I'm not going to spend a lot of time here. It's something you can go look at. We just wanted to present a few of these things just to tee up and pull together the rest of the demo. And then finally, on the pervasive insight front, this is a matter of getting the information into the right people's hands at the right point in time. So again, I can't stress this enough. Sometimes faster is not just faster. It completely changes things. So think of the case where you're trying to run the business on reports. Okay, that gives you one view into it. But if you can do real-time analytics and real-time BI such that when a customer comes up in front of someone, a customer service agent, they can see the profile of that customer, they meet their individual needs at that point, it leads to a completely different experience. And that is a couple of things there. It requires the ability to deliver the insight and the BI operationally out to the edges. And it requires the back end to be just as available, just as scalable, just as reliable as the core operational and transactional systems have been for a number of years. So big transformation there as well. So final thing we'll look at is sort of the how do we look at the business using a lot of this stuff in the back end. So with that, I'll turn it back over to Zach, and he'll show us that.
So in this part of the application, the scenario is that I work for Trey Research, and I'm going to be in LA for PDC. So while I'm in LA, I want to go visit some customers. So I'm going to use this application to help me determine which customers I want to visit, and then give me some market demographics that are specific to that geography, and get some customer information. So let's take a look at it. So on this application here, what we've got is we have all of these polygons that you see are stored in SQL Server, and they represent the different metro areas around the LA area. And they're colored based on our customer density. So I'm going to go travel south on 5, and I'm going to go visit a few customers down in this area. I can see I've got some sort of medium density customers here. So I'm going to go down in that area and make some visits. So when I select those, if you noticed, it was checking these checkboxes over here for me. And this is essentially a way for us to visualize some of our data, and then we're going to pass these cities that are selected into reporting services report as parameters. So now I'm generating a report, and this report I'll use to, like I said, get some local market demographics and to get some more information about our customers. So here you can see I've got some age distribution, I've got ethnicity, I've got tag distribution. So this actually represents the content items that fall within those polygons that you saw on the map that I'd selected, and the distribution of the type of content I have in there. So I know when I'm going to talk to my customers what kind of content I may have to sell to them. And then I have some sales information here that I can drill into to see maybe where do I really want to focus this trip on. So if I look here, drill in, I can see in this spark line chart that sales in Cerritos seems to be falling off. So why don't I drill in there and get a little bit more information, and I can use this to then go talk to my customers. So here I've got some specific information for Cerritos. It's doing spatial queries in the background to drill into that. I've got photographer information, which our photographer profiles are stored in SDS, or not stored in SQL Server. So you can see we're mixing and mashing data types into one report. And then some more customer details down below. And I could do a bunch of cool stuff like export this to Word or different formats, and it's really a good experience. So let's drill into those a little bit more. Let's see. There, Word, export. So if we drill into those reports a little bit more and look behind the covers at the spatial queries and prove to you that this SDS thing is really working, what you saw in the keynote wasn't any sort of demo magic, I promise.
Yeah.
So here, Report Builder. So Report Builder 2.0 was released about 2 weeks ago, and it is a tool built for information worker, sort of a power information worker, to be able to build reporting services reports, and it generates the exact same RDL that can be used in Visual Studio and Report Designer in the Business Intelligence Development Studio. So I could save this and open it up in either one of them, depending which environment I'm most comfortable in. So here what we've got is, let's take a look. This census database, that's the local SQL Server Enterprise database that I've got. I've pulled in some of my sales information. So then if we look at the sales by city, which is that Spark chart that I drilled into for you, and then look at the query that's actually being run here. So if any of you haven't seen spatial queries, we'll take a look. So basically, I select my columns like I want to, as I normally would. And then here, this metro areas. So these metro areas are the polygons that we saw that were red, yellow, green on our map. You can see I'm using a spatial index, so that really speeds up the performance. And then I'm joining my customer table. So my customers, we also have a geo location for our customers. So we're going to join our customer table, and here's the syntax of the spatial queries. There's a bunch of functions that have a ST in the beginning of them. So location is the column that represents that polygon, and then we're using the ST intersects function, and then we're pointing at it to the location of our customer here. So we're passing our customer location into this ST intersects function, and that returns all of our sales per customer in that area. So really, spatial is not any more difficult to work with than any other sort of SQL query. It's just a matter of getting it into your database and getting your applications able to understand spatial relationships. So it's really cool, really powerful. The other thing here, so the tag distribution, like I told you, is a SDS report down here. So we have another data source in the same report for SDS. If I look at that and drill in, it's like you'd expect to see. Oh. Zoom it. Okay. So it is as you would expect. Here we're passing in our SOAP endpoint that it's pulling all of our data from, and I've got my credentials saved in this report. You can see SQL Data Services data type here, or data connection type, I should say. And then if I look at the query here, same thing. It's another query that we already looked at. It's a join query with a little bit different format where we're selecting from multiple entities, doing our join, and then counts and putting them on the same report. So with that, hope you can see that SQL Server provides a platform for rich analytics and visualization and business intelligence across the platform. It's really, really exciting.
Zach, thank you very much. I know a lot of work
you.
went into this on behalf of you and everyone else who was working on it. I thank you.
Thank you.
So it was great. Great demo.
And I was going to say those 4 weeks, it was some rock star developers.
Yeah.
So, but I know there's a lot of those out in the audience here, so I don't think it's something you couldn't do either.
Yeah, great. Good stuff.
Thanks.
That's good. So again, this was, before I switch over, obviously an overview talk. And the idea in this was to give you a sense for what was possible, a sense for what is different. I want to spend a minute or two, we've got some time to talk a little bit more about what is different and probably how we're going to look at things going forward. And then what I'd like to do is open it up for questions. And what I would like from you are the questions. It's been fascinating to walk the halls today. There's a whole bunch of speculation. And I think we could really clarify some things just by having a bit of Q&A. So we've got the time to go off and do that. So we've got some other folks from the team around here. So we'll answer your questions as directly as we can to make sure that there's some clarity. Because this stuff is different, and it does enable new scenarios. And so I want to make sure that you walk out of the room with as much clarity as possible. And the other thing I'll show is a list of other sessions. So we didn't drill deeply here. There are many, many sessions that will go into the Sync framework, many, many sessions that will go into SQL Data Services, a session that will go into how we built it, many, many sessions on SQL Server 2008 with spatial capabilities and business intelligence and such. And so this is meant to be sort of an overview, sense for what's different. So going forward, I want to just sort of share some of what we're scratching our head on. So one of the challenges in this services space is to separate what I like to call logical and physical data administration. So we want to set up a world whereby logical data administration, what the schema looks like, I want to add a column to something, is in your hands. But physical data administration, is this particular disk drive full or is this particular disk drive squeaking and about to die, is in our hands. Okay? And that's a lot of what we've done is to make the system self-healing and to make it just keep going. So we refer to this as, 7 by 24 by 365 operations with 9 by 5, operation staff. So if something dies in the middle of the night, we'll take care of it next Friday when we go walk around. Gopal's in the back of the room has built a lot of the underlying foundation to enable a lot of this seamless failover and healing, and so it's a lot of work that goes into it. If I step back and talk about the logical and physical data administration, one of the challenges that we have is that SQL Server and SQL in general was not designed from the outset with this separation in mind. So here's the real simple example. Think of the create database statement in SQL Server. Now, create database at the top level is a logical command. I want to create a container in which I could place schemas and create tables and such. But if you keep going down the syntax tree, you're going to wind up saying, oh, hey, and by the way, put my log file on the E drive and put this file over here. That's physical data administration. One of the things that we need to do is to figure out how to pull those apart. And that will cause us to shift things around in terms of how we go off and deliver this. Another thing that we need to work on is governance. In your own world, if you write a query that runs away and goes for a half an hour, sort of that's on you to figure out. What we want to do is to maintain this cost point and make this thing such that it takes care of itself. You're just worried about the logical side of it. So things like writing a store procedure has an infinite loop in it. How do we go manage that and govern that? So naturally, as we start out, we will restrict some of the things you can do with the system to make sure that we can stay separate in terms of what's logical and what's physical and how we can scale and grow the system. Over time, we'll add more and more capabilities in at the bottom layer in terms of SQL data services. We'll add more and more capability in terms of the types of things you can do at the next level above, if you go back to that picture that we showed before. So that's just to give you a sense for how we're thinking about this thing inside the development organization. But I'm frankly stunned at what you can do with it today. I think this app is a great example of motivating that generic data hub. And I went into this a year or so ago thinking that it was a lot about, well, I'm going to go build an app, and do I deploy it up here? Do I deploy it down there? It's not that case at all as I think about it more. I see more and more examples where it's about extending and enabling new scenarios rather than I'm just going to take this thing and move it over there. And so there's a lot that we're learning. As Ray said this morning, a lot of what we ask from you is to help us learn such that we can help you, make the best of this. And I've heard people run up and down the hallways, there's no way I'm moving my enterprise data up into that stuff. No way I'm going to, and so, ask the questions here in a couple of minutes, and we'll tell you how we're thinking about that. We do have ideas. We have heard a lot of the questions. And for those things I think we have answers for, I'll share them with you now. And for those things we're still scratching our head, we'll tell you that as well. So with that, let me just sort of close with one slide. Conclusion-wise, data is no longer being generated and consumed within one app silo. 20 years ago, the data got into the database because it went through the app. And if somebody did something with it, it kind of went back out through the app. We saw a lot more of the data moving basically in a different flow, a content flow that wasn't bound directly into the application. We see that more and more in sophisticated data applications. Evolution of the database to a data platform. And again, it's not about more features and running on more different scales. It's about tying it together in a way that works. The Sync framework's a great example of that. This model-based development, the entity data model, and how that evolves would be a great example of that. SQL services, I hope we pointed out that it is enabling new scenarios. So it's not a replace in kind, try to do it a different cost point. It's about new scenarios that are very, very hard to go off and build today. And key thing here is I think of Sync a lot of times as the plus in software plus services. You saw about how we get running a rich client that's offline enabled in a way that you can go off and build yourself without having to get 20 or 30 rocket scientists together to figure out how you're going to get the Sync together. We've had our own rocket scientists who kind of put the pieces together for you. So the data platform in the large enables a reduction of latency. And I think this reduction of latency is important both in terms of the data. So think about it. We took a picture up here, pressed the button, the picture wound up in the service, wound up down in the application for someone to go tag in a matter of seconds. It's about the solution development. Zach mentioned they put this together in a matter of weeks. This would be unheard of 10 years ago. If you had the compute power, if you had all the pieces together, just the platform wouldn't be sophisticated enough to be able to develop it in a matter of weeks. And then the business processes. I tried to tee up the scenario by saying that once you get the friction, once you get the latency down to a certain point, it's not just lower friction, lower latency, it enables new things. So imagine what it takes to make a marketplace here in this photojournalism scenario. So, and ultimately, it's about getting more value from your data. So with that, we'll sort of turn it over to the related sessions. So you can take a look there. I know it's an eye chart. Point being is that this was meant to sort of open things up in terms of what was possible. The sessions are there to be able to drill in to whatever level of detail that you want. And of course, there are a lot of people down in the lounges, a lot of activities you can do in the hands-on labs. And so I invite you to go off and do that as well this week. So with that, let me turn it over to questions. And I do encourage you, please go up to the microphones. That way they can record it and get it on there. And I'll take one that I'll repeat while a couple people want to go up to the mics. There's one up front here. Yeah. Yeah, great. If you can just grab the mic. So
if you're dealing with something that's a really high-end web scale,
yep.
So you want to use SQL data services, do we have a choice that we need to make between consistency and availability in the cloud? Is that like a policy thing, or is it one size fits all?
Okay, so the question, that, a couple ways of interpret is there's a trade-off between consistency and availability, and I see Pat back there. So funny story is that Pat and I, one of the first things we did when we came to Microsoft back in the mid-90s, Pat Hallin's back then, is we worked on the two-phase commit work in SQL, which was sort of consistency and anti-availability, sort of that end of the spectrum. Both of us have learned a lot. And so part of what we're doing is dialing it in, and there is a trade-off with respect to consistency. And there are new app patterns that are consistent at one level, but relax it a little bit. So a lot of times we look at queuing, and durable queuing is a means for decoupling components of applications. And so to answer the question fully, requires a response at various levels of the platform. One of the things we're going at with SQL data services is to make it consistent at the data tier and then be able to compose out of atomic database transactions these higher level app constructs that give you sort of a relaxed consistency, higher availability. And that's probably an offline topic we could spend an hour or two at. So yeah, question back there.
If I build an app and deploy it on Azure today or in the next 2 weeks, can I use SQL data services in the cloud from my app?
The answer there, I believe, is a yes. I'll look in the back of the room. Sumitra, is there any reason I should be wavering at all on that? No. Okay. So the answer is yes.
So we are registering now to get a key, a token for Azure
Yes.
apps. Do we register for a separate token for SQL data services?
There's a gentleman in the back there, Tudor, raising his hand, who can give you the answer to that.
Same token for both?
Yeah, the same provisioning will give you what you need to be able to compose and write across both of those.
Thank you.
Yeah. Thank you. Good question. Anyone else want to go at it? Take a couple more. Okay, there's a question coming out.
I'd like to know if there's any impacts, either positive or negative, in respect to internationalization when using SDS.
Mm-hmm. So the question, internationalization with respect to data. There are issues with respect to where the data resides, and we're looking at those. We have a lot of people who are familiar with it from our services, from existing services that Microsoft produces, and from the Business Online group. So it's something that we are looking at, and we're looking at a number of different ways to go make that work. And it's both a, if you will, regulatory sort of thing we need to look at it, and also just a performance in terms of geolocation and geoscale and such. So yeah, it is. We will be building out data centers around the globe to facilitate a fair bit of that. Okay. A question up front?
So with not trying to force like SQL data services and making it, SQL Server replacement, which I think you're trying to say it's really not, like, I think most people are developing applications right now. You have a web server, app server, and you have SQL Store somewhere. And, even with WCF coming out, they had endpoints. Some were TCP binary, some were HTTP, and you had obvious benefits. If you were within the local area network, you might want to use the net TCP binding, et cetera. So if I'm deploying a web application, into the cloud, that's using SQL Server, Am I being forced now to use more of a SOAP type level communication and be pulling back a whole bunch of data? And is that going to be it from here on out? Or are you looking at more efficient ways of getting data?
We are looking at more efficient bindings for running the app next to the data in the data center. Yes, we are.
Okay, and then you mentioned one thing early on was as far as we don't have to provision to scale out. Mm-hmm. So does that mean you're going to be handling the partitioning of our data, like either it's in some horizontal manner, I'm assuming, that you're going to do the aggregation service for us, or how is that all going to work?
So in fact, this would be a good topic. They will go into it in some of the drill down sessions on SQL data services. But the idea is that we will provision a tenant and make sure that they stay within a scale unit. And what we can do is actually replicate that. And every tenant, we will make sure that it is, if you will, distributed across a set of scale units and replicas. Now, there will also be times where we want to do work and queries across scale units. It gets to that question around consistency versus availability. We will build the means to go off and do that. A lot of times in large systems, so we run into two principal patterns that we see. We sometimes refer to it as the millions of littles. It's like imagine millions of little applications, each one of them, if you on the fabric. And then there are the applications that are just the one big large, but they might be partitioned into lots of different entities. So you can imagine an address book for the internet would be an example of the latter, and are a very, very large scale system. And sometimes what you want to do is build an index or look at it in a different way than it's not the way that you've principally partitioned it. And so we were working on the infrastructure to be able to go off and do that. So we call these things global materialized views. So we can actually produce data out of one partitioning form, repartition it into a different way to support queries and such. And so we'll do a lot of that under the covers. We'll make more and more of that part of the platform over the next year or two.
Okay, cool. Thanks.
Yeah, take one back there.
I was wondering if you were going to put that tree research sample up on the net somewhere or document the mapping
Let Zach take that one.
from the SDS to the
So there's
SQL server
a previous version of this that was more around a blogger news scenario that would probably be more appropriate for us to publish because it's just further along in code maturity. If you want to check out my blog on MSDN, it's blogs.msdn/zowens, and I'll publish some things up there over the next few weeks as we get that previous version ready, which has a lot of the same capabilities and the same basic framework.
Okay, thanks.
I have a quick question about the development experience. Do I always have to be online during development time, or can I spend some couple of hours in the plane to develop my app, or is there anything that will help me?
So the question is, can I develop my app against SDS sort of offline? We don't yet have a local version of the service. It's something that I've been asking the development team for some time. Ultimately, I think that we will, and that's part of the plan, at least in my head. We'll see if we can get it done, but not right now. Yeah. Back there?
Yeah, a couple questions regarding performance issues. And say today on SQL Server, you can find out, for instance, if something's performing bad, you have graphical query plans, things of that sort. And I was thinking, well, with simple maybe retrieval, even simple joins, maybe you wouldn't have much of a problem. But then I'm thinking, well, even with a large data set, if you have a query, a where clause that SQL Server doesn't recognize as being selective for different reasons, maybe you have a column in a function, or the particular column you're selecting on just isn't, it's not very selective. You can have very bad, performance. And so is there some visibility today that you have a bad query, executing, besides just seeing that it's very slow? And the other question, it does seem like the report aspect is going to be ripe with performance possibilities for bad performance.
So the question is, around performance and how do I monitor it, how do I manage it and such. And so there are many different answers there. One, our tooling right now is not that sophisticated, and we'll add it. I mean, ultimately, we're working with Microsoft Research to have ways to say that let's just have the system recognize it and tune for itself. So some of the database tuning work physical database tuning work we've done within SQL Server with MSR is very advanced. We want to take some of that and get it into SDS. The other thing, which is not really an answer to your question, but it prompted me to respond in one way, is that what we found as people use this, there's a pattern whereby rather than specifying sort of complex and precise queries, which they would do in a typical database application. Quite often we see people, I would say, writing sort of the spanning or bounding queries, where they just basically get the set of entities in the system that they want back. The query form is a little bit more simpler. They pull the data back and then locally work with it. Because you have to realize it's a it's a much larger latency to go get it and bring it back. And we're working on means to be able to operate on it in a rich way, close to the application, close to where the power is, and then maybe put it back. So we have a lot of work to do in that space. And we'll see more tools first, then you'll see automation, and then you'll see new app patterns as well. So, thank you.
Will you be at the experts section to discuss this kind of stuff?
Oh, you'll find lots of experts at the
Okay.
experts session.
Sounds good.
And I'm there as well. Thank you. Yes. We'll do two more, and then we'll wrap it up.
Slightly off topic. Some of the industries we work in are regulated, and the data itself and the application are covered under regulatory constraints. Have there any been thoughts on how you do that within a cloud environment? We were talking at lunchtime, one of the questions, about how we would take our data from the shop or from the plant and then publish it out to the enterprise, and who then owns that data and who's responsible for it?
We spend a lot of time thinking about that. We've had very interesting discussions with the EDA and PLM vendors because they face this. And I don't want to go into the details here because we are working with them and with MSR and such, but it's a very hard problem.
So there are thought processes.
There's thinking in place going on in that one. So,
all right, thank you.
Sure. One more question.
Yeah, my question was connected to that. What about security, privacy, and stuff like that? So I'm going to push all my data out there on the internet, and who can look at it, or can I lock it down for some? Because at your site you have got all the physical guys, but they're probably also having access to the data and seeing it and stuff like that. And if I don't want anybody to see it, but I do want to host it externally, how would that work?
Yeah, so the question's around privacy and security of data and such. And I think that that's something that comes up top of mind with people when they think about this. And I think if you step back and look at most of the leaks that we've seen of sensitive information today are in different forms. Someone's carrying around with a laptop and the laptop gets stolen. And people today are putting data. So you ask how many people have their payroll done inside. Well, the payroll data is going on. A lot of people have email hosted somewhere else, and email's sensitive information. So I think that you're right that we do have a lot of work we need to evolve. I think there's some answers. Cryptography plays a role in encryption in some form. But we are sort of early in this. We're working on the generic data hub scenario. I think becomes much, much richer when we can write interesting authorization policies against the database. The federated identity gives us the authorization. Too often do that. The authentication. And then, but it will be some time, and people will become more comfortable with it. But quite often, what I find is when I point out places today where a lot of leaks are occurring, they realize that those are probably bigger holes than what they would encounter going, with the data hub that we can secure. So, I want to acknowledge the fact that it is an issue, but it's something again that we spend a lot of time thinking on. So,
and I think a really cool aspect of a conference like this is, like you mentioned, over in the lounge there, you have like the Cloud DB, the SDS architects there. So grab one of them and have a conversation, provide some insight into what you'd like to see happen. I mean, it's really an opportunity where everybody here who's building the system is trying to get feedback and get good ideas from everyone.
Yeah, this again, I'll just highlight this one thing and we'll close. It's an amazing shift. And I've been working on SQL Server for 14 years, and we turn the thing, we scratch, and we get it out every 2, 3, 4 years. We have 8-week sprints that we're doing in SQL Data Services. So every 8 weeks, we're putting out new bits that incorporate new thinking. So the ability for us to learn and turn this very, very quickly has been increased immensely. So this is going, we want to get it to a point where you can actually use it in a real way to give us real feedback. But we should be able to really incorporate that feedback quickly and evolve the system really, really fast. So with that, I'll close. I want to thank you for spending the time. Hopefully this is sort of a broad view that you can use, and enjoy the rest of the week.